Okay, so continuing on with dilations. Remember, we've talked about dilations as the only transformation that affects the size of a shape on a coordinate plane. Well, with dilations, we talk about where it affects the area and perimeter of a two-dimensional shape. So we're going to go over some basic, stuff you known from 5th, 6th, 7th grade, area and perimeter. So this is our first time seeing true geometry, like in a sense of shapes and angles and all that. So let's break it down, okay? So dilation, just keep in mind, is the operation for dilation is multiplication. So with that, first, let's talk about the dimensions. So they're saying that figure 1 was dilated by a scale factor of 2. That means that they multiplied. Oh, wait, we want us to find the scale factor. They was dilated to create a larger rectangle. Well, look at what happened. One side of the rectangle was 2 units, and then it grew to be 4. The other side of the rectangle was 6 units, and then it grew to be 12. So what did I multiply by to get from 2 to 4 and 6 to 12? Well, I multiplied by 2. So that means the scale factor was 2. Well, then, that being said, let's see how that affects the area and the perimeter. So if I know that the figure 1 has dimensions 2 by 6, what do we do to find the perimeter of any shape? If you remember back in 6th, 7th grade, to find the perimeter of any shape, you add up all the sides. So in this case, I would add 6 plus 6 plus 2 plus 2. So that's 12 plus 4, which is 16. Okay, well, let's find the perimeter of the bigger figure that was multiplied by a scale factor of 2. If I add 12 plus 12, that's 24. 24 plus 8, that is 32. I can do math. Okay. Even though the dimensions were different, we had a perimeter of 32. Well, what happened from the old perimeter to the new perimeter? What did I multiply by to get from 16 to 32? Well, I multiplied by 2. Let's see if that's true of area. So here, the area is different. Remember, perimeter, you add up all the sides. To find the area of a rectangle, you do length times width. So if I do 2 times 6, the area of figure 1 is 12. If I do the length times width of figure 2, 4 times 12 is 48. Did I multiply by 2 to get did I multiply 12 times 2 to get 48 here? No. What did I multiply 12 by to get 48? Well, I multiplied by 4, which in hindsight just means I technically doubled the scale factor. So for a perimeter, all you do is multiply by a scale factor of 2 to find the new perimeter. And then for area, I multiplied by 4 to get the new area. Well, let's see what happens on this next shape. Okay, let's see if we can see a pattern. So if I look at this shape, it's a whole new rectangle with different dimensions. This one's 2 by 3, and this one's 6 by 9. So what was the scale factor? What did I multiply by 2 to get a side of 6? What did I multiply by 3 to get a side of 9? Well, we multiplied by 3. So we're going to assume that the scale factor is 3. Okay, well, let's see how that affects our perimeter. To add all the sides, 3 plus 3 is 6, plus 2 is 8, plus 2 is 10. So the original perimeter is 10. When I add 9 plus 9, that's 18. 18 plus 6 is 24, and 24 plus 6 is 30. So what could I multiply by 10 to get 30 for this new perimeter? Well, I multiplied by the scale factor, by 3 also. Well, let's see if that's what happens when I do area. Length times width is 2 by 3, which is 6 for the small rectangle, and 6 by 9 is 54. Did I multiply by 3 to get 6 by 3 to get 54 for the area? No. What did I multiply by 6 to get an area of 54? Well, I multiplied by 9. Okay, so it wasn't that the 3 doubled. Let me think about something. Make the connection here. If you think about area, okay, area when you think about, perimeter versus area. Perimeter, if I asked you 10 is the measurement, that would be 10 units. Versus if I asked you for the area, that would be 6 units squared or 54 units squared. Remember back in 6th and 7th grade, that's how you labeled the measurements. So if I ask you this, okay, to the difference between perimeter and area, perimeter here is just the same thing as the scale factor that it was originally. Versus What could I do to the scale factor to get 9? What did they do to the scale factor to get 9? Same thing here. What did they do to the scale factor to get 4? Let's see if we can keep going and find another pattern. So if I look at a triangle, okay, the dimensions of the triangle are 9, 12, and 15 for the small one, or the big one this time. This time it got smaller, and we got 3 by 4 by 5. So this time the scale factor is going to be less than 1 because it got smaller, didn't get bigger. If I ask you for the perimeter of the big one, we got 9 plus 12, which is 21. 21 plus 15, 21, 31, 36. Versus if I look at the new perimeter, the smaller one, 3 plus 4 is 7 plus 5 is, I can do math, 12. So how did I get, or I'm so sorry, I skipped a step there. How did I get from 9 to 3? How did I get from 12 to 4? Or how did I get from 15 to 5? Well, if you remember how we did this with dilation, remember you put the new one first. So I'm going to put 3 on top and 9 on bottom. 3 over 9 is equal to 1/3. So the scale factor is 1/3 because it got smaller. Now that being said, how do I get from 36 to 12? Well, that's also 1/3. I would have to multiply 36 by 1/3 to get 12. Well, let's talk about area. So area of a triangle is a little different because it's not just length times width, 9 times 12. It's 1/2 length times width. So that would be 54. Same thing for the small triangle. It's not just length times width. It would be length times width times 1/2. So that would be 6. Well, how do I get from 54 to 6? Technically, it's almost like dividing by 9. Or if you think of it like 6 over 54, new over old, 6 over 54 is 1/9. Well, where did 1/9 come from? Now, here's the connection, which probably all of that kind of went over my head and yours, but let me make the connection here. If I think about perimeter, like the first example, when I had a scale factor of 2, it not only doubled the dimensions, it doubled the sides, the perimeter also doubled. I multiplied by 2, okay? When I doubled the dimensions, the area is not just doubled, its measurements were 2 squared because 2 squared equals 4. It was quadrupled. When I multiplied by 3, when I tripled something, the perimeter is tripled also. That means I multiplied by 3. But whenever I tripled the dimensions, the area is not just tripled, it's, I guess the term is multiplied by 9. It was 3 squared, which was 9, okay? And then if I multiply by 1/3, the perimeter is also multiplied by 1/3. And then the area was multiplied by 1/9 because it would be the same thing as saying 1/3 squared, okay? Here's the simplest way I can break it down for you, okay? Perimeter is one-dimensional. So that's why if I multiply by 2, I multiply by 2. If I multiply by 3, I multiply by 3. If I multiply by 1/3, I multiply by 1/3. Area is technically two-dimensional. So like length times width, it's not just doubled or anything like that. It's squared. So area is squared. Whether it's 2 squared, 3 squared, 1/3 squared, 4 squared, 6 squared, whatever the scale factor is, we square it. If it's perimeter, the scale factor is the scale factor. So the takeaway from this entire lesson, as overwhelming as it may be, is if it's talking about perimeter, it's just the scale factor that's being multiplied. If it's area that it's talking about, it's the scale factor squared. So perimeter is scale factor, whatever it is, versus area is scale factor squared.